Let's take a look at computing and graphing inverses. From last time, this is the definition that we have. We use bubble and arrow plots, A, B, C, D, E, F, to show relationships. So we know this is a function because every x value goes to exactly one y value. We also know that it is a one-to-one function because every y value has only one x value. Now, what we like to look at is to go in one direction, we're using f of x. To go in the other direction, we're using the inverse, f inverse of x. And this is why we cannot have a y value over here that has two different x values that it has to choose from to go backwards. Next, let's actually find the inverse function. We know f of x equals x minus 4. Let's call that y x minus 4. On the previous slide, we were switching, going back and forth, domain, codomain, and then those switch. We do the same thing here, where we switch the x and y values. So y becomes x, and x becomes y. Now we need to solve for y. When we do that, we add 4 to both sides. And we can switch the order of the equal sign just because we like the y on the left. And then last we need to rename this because this is not really y. We did the switch just so that we could conveniently switch the domains of x and y. But we need to rename it as the inverse. So here we have f of x and f inverse of x. Next one. It doesn't matter what the function looks like, we can still find the inverse. We know from last time that this passes the horizontal line test, so it is one-to-one, which means it does have an inverse. Let's call this y. And then we're going to switch the x and y. We now need to solve for y, so we're going to take the cube root of both sides. That means the cube root of x equals y. Switch the order because we like it on the left. And now rename it. We have found the inverse of x when f of x when this is the original function. We can do this graphically as well. So when you're given the graph of a function, we know we're switching domain and what we would call range, and we call codomain with bubble and arrow functions. So let's start with this point and switch the 0 and negative 4, so we're switching the x and y values. That gives us then 0, negative 4, which is sitting here. Do the same thing for the 2, 0 from 0, 2. And then lastly, from 5, 3 becomes 3, 5, so 3, 5. That allows us then to graph the inverse. You'll note that anytime you do this, graphing of a function and then graphing the inverse, sorry, that's not really straight, that those are a mirror image across the line y equals x. You can do this with any function graphically by picking a couple of points and then smoothing the curve between them. Lastly, let's verify that f of x and g of x are indeed inverses. To do that, we're going to compose them, f composed of g of x, f of g of x, put g of x inside the parentheses, 1/2 x minus 3, and then we're going to substitute this in for the x value. So let's make a spot. And then take the 1/2 x minus 3 and substitute it in there. When we do that, 2 times 1/2 x gives you x, 2 times negative 3 is negative 6, plus 6, and you get x. Let's see if that happens the other way. G composed of f of x. G of f of x. Now let's put the function f inside there, 2x plus 6. Now we're going to substitute this into the x value of g, So let's leave a spot. 1/2, whatever we're substituting in for x. And when we do that, 2x plus 6. Let's see what we get. 1/2 times 2x is x. 1/2 times 6 is 3. Minus 3, and you get x. So when two functions are inverses, f of g of x is going to equal g of f of x, and it's going to equal x. One last thought to leave you with that is very interesting is, let's find f of 1. F of 1 is 2 times 1 plus 6 is 8. Now let's find g of 8. G of 8, 1/2 times 8 minus 3 is 4 minus 3 equals 1. And look, we went from 1 to 8, and then from 8 back again to 1. So we were really looking at bubble and arrow. We went from 1 to 8, and then we went back again. Thus is the life of an inverse. Hope you're having a great evening.